All right, when we first talk about the multiplier effect, it is important to grasp what all it includes, and it includes a lot. So a lot of times we think of delta G, we think of, hang on one second, we think of delta G for delta T, or maybe it's 1 over R. And these are all good examples of it. However, these all employ the multiplier effect. The overall multiplier effect idea uses those in it, but the idea as a whole is just what we're going to talk about. So let's start with some definitions and explanations. So the multiplier effect is the increase in consumer spending that occurs when spending by one person causes others to spend more too. Or in simple terms, it's how much of your additional income you turn into spending. So if I gave you $1,000, how much of that are you going to spend? And a lot of times we think of that as marginal propensity to consume, which is what we would use to calculate. So our MPC is pretty easy to calculate over here. It's just delta C over delta Y, and this would give us our MPC. Really not complicated, but that's a concept that we will use a lot of. Now, for these next examples, there's stuff that you've seen. We're just going to apply it in a different way and kind of show the emphasis of the multiplier effect. So multiplier effect is often used in the expansionary or contractionary policies and calculated to determine how much GDP will change as a result of this newfound income, which is great. So that's the overall view right here. You need to remember that. But you also have to remember that there are lots of other factors that the multiplier effect comes into. So we'll see it with banks and how when they get a deposit and then they issue a loan, how it multiplies there, and it's another multiplier effect. We'll see it with the change in government spending and the multiplier effect there. We'll see it with the change in taxation and the multiplier effect there. There's a lot of examples of the multiplier effect. So to start, we're going to look at, or really, we're just going to look at this one problem, but it's one that's good and it helps you grasp it in a different idea. I know there's already a video on taxation multiplier and government multiplier, so this one is about the bank multiplier right here. So to start, we have to declare what our I is, and then or our R is right here, and find our multiplier. So it's pretty easy. Our R, it gives it to you your reserve ratio. That's what your R is. Reserve ratio is 15%. So our multiplier equation is just this. It's 1 over R. Easy enough. So it's 1 over 0.15. Nothing crazy. I think this may even be in your notes. I'm just trying to give you a different explanation to make it a little simpler on you. So this is going to be 6.67. We're rounding. And this is for 15%. It also asks us what if it's 40%. So we're just going to go ahead and plug that in over here. That'd be 1 divided by 0.4. That'd be 2.5. Okay. So this is your multiplier for both of these. At 15%, we have 6.67, and at 40%, we have 2.5. So now we have to solve for how much the supply of money would change. And at supply of money, this is actually really easy to find. All you have to do is the change in the supply of money equals a deposit times that rate that you just found, so 1 over R. So we already know this. It's either the 6.67 or the 2.5. So we're going to have to plug both of those in. And our deposit is the constant of 1 million that's being deposited. So 1 million times, we're going to do 6.67 first. And we'll solve this and get 6.67 million. Easy enough. That's how much the change in supply of money will be. Or we could solve for the other one, which is 1 million times 2.5, which would give us 2.5 million total change in the supply of money. Really not a super hard concept. What's difficult about this is remembering that the multiplier effect plays into this. So everywhere you see the word multiplier, it typically has a form of the multiplier effect. That's just a little cheat for you right there. If it says multiplier, there's some form of the multiplier effect. However, it's used differently, as we saw in the video on government spending and on taxation. You can see how that works slightly differently. This right here, remember, is referring to the banks. So when they take a loan, they give a loan to you, you pay someone, and then they pay it back to the bank in a deposit. And now it's just this ongoing cycle that we're back to loans over here to start. And it's this repeat that turns into a multiplier effect that would give you all this down here, which is what we just found. So our supply of money change is 2.5 million, 6.67 million. So the other thing to remember about this is your reserve ratio. This gives you a little note for further. If your reserve ratio increases, then the change in the supply of money will decrease. And why is that? It's because we're going to go back to this page. So if you can only give out, say you're required to keep 50% and you get 10 million. Well, if you have to keep 50, so 50% reserve, then you can only give out 5 million. So this is contractionary policy right here. However, if our reserve goes down to 10%, it's pretty easy to see that of the 1 million, all you have to do is keep, or out of the 10 million, you just have to keep your 1 million right here, and then you can give out 9 million. So if we lower this reserve requirement, lowering reserve is expansionary. That kind of goes into a little bit more, but overall, we just have to remember the multiplier effect and the effects that it has whenever it comes to definitions, which we have right here. I'll show you one more time. And it's just the increase of consumer spending whenever you have additional capital or additional income, and how much the percentage of it you would spend, which is your MPC, which is calculated delta C over delta Y. We use it to determine expansionary, contractionary policies and calculate how much the GDP will change because of it. And an example to work out with banks using a multiplier effect, it's just this one we worked out for you. I hope this is helpful, and I hope you remember the multiplier effect.